Hello, welcome to our first lesson on electrostatics. Okay, all right. This lesson will go through the introduction to electrostatics, what it means in physics and also in mathematics. Okay, if you have not subscribed to the channel, kindly subscribe for more videos and also support the channel as well. Okay, all right. Let's start. Okay, when you say electrostatics, what do we mean by electrostatics? Okay, so I have a simple definition here that we are dealing with this electrostatics. It deals with the study of forces, okay, forces, fields, and potentials arising from static charges. This word is very, very important. Static charges, meaning the charges we are coming to do with, they are both or they are all static, meaning they are not moving, okay. All right, so then what do we mean by electric charge? If you talk about static charges, what do you mean by charges? Okay, charges here, by charges here we mean the electric charge. Okay, so electric charge is a physical property of matter that causes it to experience force when placed in an electromagnetic field. Okay, so if you know electromagnetic field small, you can see that when you have a charge or if when you have a particle and that particle is charged or it's a charged particle, it means that how the particle will move through that magnetic field will be different. Okay, there will be some deflections and you know a whole lot of things. Okay, but we have two types of charges, or two charges we know to be positive and negative. And remember, like charges attract positive will attract sorry positive will attract negative. So what you have to know is like charges. Okay, let me write it this way. Like charges repel. Okay, so like repel. Okay, and unlike attract. Okay, unlike charges attract. So you should know this. I decided not to add it because I thought maybe you'll be able to understand, but I just wanted to mention it that like charges repel each other and unlike charges attract each other. Okay, so that is one thing you should know about electrostatics. Now let's move forward. Okay, we call something charging in electrostatics, and when we mention charging, what do you mean by charging? Okay, so charging simply is a process whereby excess electrons are added or taken from a body. Okay, so basically what we want to say is that to say that a body is charged depends on the amount of electrons the body has. Okay, but now I believe you know something small about the subatomic particles. Okay, the structure of the atom. Okay, so if you have more electrons than your protons present, okay, automatically you are negatively charged because you know that the electron is negative charge. Okay, we will discuss about these stuffs, but I just wanted to mention it. Okay, and also if you have less electrons than the proton and you are positively charged, automatically all matter that we see around us is neutral unless or until an excess electron is added or taken away from the matter. That is when you can classify the matter to be positively charged or negatively charged. Okay, that is why we say that it's a process whereby excess electrons are added or taken from a body. We have three methods of doing this charging. You have friction, you have contact, and induction. And in all the processes, there is one particular law that is being conserved here. Okay, the law of conservation of charges. You state that the net amount of electric charge produced in any process is zero because if I pass through all these processes, friction, contact, induction, after everything, after the process, after the charging process, the net amount of electric charge that will be present here is zero. In the process that I'll withdraw, no net electric charge can be created or destroyed. Okay, so anyway you want to go, that is okay. Alright, so let's start with the friction and talk about the friction. So charging by friction, this is a process whereby two neutral bodies, okay, so two neutral bodies which are not charged, they are neutral bodies, they are being rubbed with each other and eventually both of them get charged. Okay, so they are what? Neutral bodies. and they are wrapped, okay, with each other, and then both of them both of them will be charged at the end. Now example is that when rubbing a plastic comb with dry hair, it acquires some charges and it attracts tiny pieces of paper. Alright, let's take it for instance. When you're done bathing and then you combing your hair, okay, after that you could see that you have some remain or particles of hair on the comb. Okay, so it's as if the comb has attracted some electrons from your hair, and in that doing the comb becomes negatively charged. Okay, so the hair loses, your hair will lose some part of it to the comb. Okay, and then at the end, if you bring a paper or piece of paper closer to your comb, it will attract the paper. Okay, the second one is, we are done with this one. So the second one is, when rubbing a glass rod with silk cloth, the rod acquires positive charge because it loses electrons, and the silk becomes negatively charged because it gains electrons. Okay, so when you rub a silk cloth with a glass rod, eventually the glass rod will lose electrons to the silk. Okay, so that is it. That is the idea here. And let's look at the other one, charging by contact. Now I'll illustrate this with a diagram. That is why I didn't bring anything here. So charging by contact, it deals with what? Charging a neutral body by the use of a charged body to come into contact with a neutral body. This is what I mean. Go to the previous one. We said that this is a process whereby two neutral bodies. Okay, so you can see that in the friction, two neutral bodies are being used, but in the contact, one is charged, the other is not charged. Okay, so if I want to charge a body positively, okay, then I'll have to bring a positive charge, okay, particle to closer to a neutral body. Okay, when I come into contact with it, okay, this is the initial stage. Now the next stage will be, the positive charge is here, okay, and um, I will attach it to the neutral charge. One thing that will happen is that you see that all the negative charges in the neutral charges will be moving towards the positive charge, so it will be attracting the positive charges. So it will be the positive charges here in this state, okay, will be attracting the negative in the neutral. Okay, so the negative in the neutral will be moving towards the positive charge. So at the end, if I put them together in contact for just 1 minute, and you can see that there will be a deficiency of electrons in the second body. If let's say we call this body 1, this body 2, okay, here body 1, body 2. After I separate them, you can see that still this will be a positive charge, though the first body, but the number of positives will reduce because some of them will get neutralized by the transfer of electrons or negative charges from the second body to the first body. Okay, and you can see that this body here will now get excess positive charges because some of the electron, there is a deficiency in electrons here in the second body after we are done with the contact. So you can see that if you want to charge a body negatively as well with the process of contact, then you have to use a negative charge. If you want to charge a body positively by the process of contact, then you have to use a positive charge. Okay, so that is how the difference is. And know the difference between contact and friction, because friction deals with what? Two neutral bodies, while contact deals with charged body. Okay, let's go ahead and look at charging by induction. So charging by induction, it deals with charging a neutral body with the use of a charged body by bringing the charged body closer to the neutral body without contact. Okay, but here you have to do a whole lot of things, because you should make sure that the contact and induction, you should make sure that your apparatus or your things that you are using, you have an already charged particle in it. Okay, so here what you do is, you first of all bring what do you call it, this is your charge particle. Okay, let's say I have a positive charge particle and I have a neutral particle like that. Then one thing you have to do is also do this, bring your charge particle closer. Okay, let me use a different sorry, let me use a different color for the neutral. Okay, so let me say this is a neutral. Now I'll bring my charge particle, which is a positive charge, okay, closer enough to without contact. Okay, we say without contact, so it's closer enough to the neutral body. Now once you do this, you could see that all the negative charges here will be assembled at one side closer to the positive charge, and the positive charges will be repelled away. That is why in the first slide I said that like charges repel each other, unlike charges attract. Okay, now at the end of this, once you see this happening, what you have to do is also do what we call the grounding. You ground the one to the earth, okay, the one that is neutral that you want to charge, you ground it to the earth. Okay, you do what we call grounding, and in doing this, since the positive charges are seem like to be attracted, sorry, the negative charges of the neutral body here, this side, the left side here, okay, see they are the negative charges. Since they are seem to be attracted towards the positive charge, it will be held at the surface of that part. Okay, here they will be held here, the negative charges, and what will happen is that the positive charges here will be moving away from the body to the ground. Okay, so they will be moving here, and so as soon as you see that the desired number of positive charges are being lost in this process, you just unground it, and after ungrounding it, this is what happens. Okay, you see that the neutral body now is having excess electron because the positive charges or the positive particle, this particle 1, okay, let me name that like that, 1 2, the positive charges in particle 1 or body 1 held the negative charges so that the positive will be able to be moved to the ground. Okay, so at the end of the process, what we have is we have excess negative charges. So you see, charging by induction actually gives you an opposite charge after the process. I don't know if you get my point. You want to charge a body negatively using induction, you have to use a positive charge particle. You want to charge a body positively using induction, you have to use a negatively charged particle to charge a body to get positive charge. Okay, now with the contact, okay, with the contact, if you want to charge a body negatively, you have to use negative. If you want to charge a body positive, you have to use positive. By the induction is the other way around. Okay, so that is the process that I will end here. In our next discussion, we'll talk about the charges that are associated with the subatomic particles, the neutron, electron, protons, and in a subsequent video, we'll be doing the calculation aspect of electrostatics. Okay, all right, thank you, and don't forget to subscribe to the channel to support it as well. See you next time.